All right. Sound check. 1, 2. So if somebody wants to just possibly try to type a message there saying they have good audio, we will actually get started here. Let me just double check on my side with the audio. Yeah. All right. So at least on my side, when I sort of enable the player, I am getting good audio. So let me go ahead and get started. So welcome everyone. Good morning, good evening, good afternoon, whatever. Whatever works for you. The comments are open, so you're free to sort of type messages as this goes along, insofar as it sort of remains on topic, respectful, etc., etc. Then, you know, by all means, please shoot, all right? I will try to keep track of the messages as they come, whatever, it'll vary. If I miss yours, just sort of, please just repeat your question, comment, whatever works for you, and we'll go with that. Okay, so welcome everyone, my name is Kareem Yagmor, and in the next, whatever, hour or so, I'm gonna try to go through what I found in Android 12. It's relatively kind of compared to other things, mostly an incremental sort of release. I haven't found anything that's sort of radically sort of new, except one thing that sort of promises to be interesting to watch over the next couple of years, which I'll get to a bit later on. But mostly this update is sort of more an organic thing than some of the stuff that we've seen in previous releases. Okay, so it'll work better with my presentation mouse if I actually plug it in. There we go. So yeah, the slides, I'll put those up after the presentation at some point later on. So, you know, whatever, feel free. If you're watching this into the future and you find something wrong with my presentation or my slides, by all means, just poke me and I'll take it from there. You've probably seen my presentations elsewhere. Just a quick background, I wrote the Embedded Linux book for O'Reilly 20 years ago, and the Embedded Android book then 10 years ago or so, and whatever. So the only question that you can't ask is, when do I update my books? Otherwise, I've been involved in Linux for quite some time, most widely known for having written the Linux Trace Toolkit, which was the first tracing tool for Linux, and help customers here and there with their Android work, and of course, with their whatever training they have, training requirements they have for that. All right, you've seen me carry this diagram for several years, which is the architecture of Android. I haven't really seen anything that changes this architecture too much in 12, at least not yet. Maybe, as I said, one of the things that's coming up here might actually have a few interesting additions to it, but rather most of it is unchanged. So Linux kernel with whatever it's got, GKI is the biggest thing that has taken place there, which I'll cover really quickly since I've already covered it quite some bit before. The native layer there with the libraries, hardware support, native daemons, etc. The Java user space with the Zygote being the engine for running Java code, and then effectively the applications on the top. All right. So I'm going to start with an update of GKI. There really isn't sort of much to say that's radically new, so I'll mostly recap what you've heard me say before really quickly before I sort of zoom in on the, I guess, one thing that's sort of interesting that happened this year. So the traditional release model prior to Treble, which is 8, effectively was that Google would pick up a kernel whenever they wanted to, put that in the pipeline, it goes out the user at some point. The problem with this is effectively that the kernels that users would get would usually be rather obsolete. So one of the things that Treble brought to the fore was the use of long-term support kernels, and the idea behind that is, since they're basing their work on long-term support kernels, that eventually anybody getting a byproduct of their own work, be it via a silicon vendor or some additional third party down the stream there, could always rebase on a future version of LTS. All right. GKI, which was introduced in 10, changes the equation a little bit in the sense that Google now releases something called GKI, the General Kernel Image. Silicon vendors then make modules, and the OEM goes out, ships their modules with the GKI modules, and this thing goes out the door. All right. So in other words, once the modules have been made available as a silicon vendor, you no longer need them. You know, at least that's a theory. As an OEM, you can sort of go ahead and make updates with the GKI kernels. So one of the things that Google has sort of used to make those GKI kernels is Android mainline, who's supposed to effectively track what Linus Torvalds does on a more or less daily basis, and then sort of flag conflicts and so on and so forth. And so this has, of course, continued, and this was sort of like a more detailed view of that. Again, if you want to sort of the long run through this, look at my video from last year for the Android 11 sort of update, and what you get is effectively GKI, which is the green stuff that you see here being in the kernel, and then Google defines this thing called KMI, the kernel module interface, which silicon vendors and OEMs write modules against, which are then sort of used to write the HALs and so on and so forth. For those of you more versed into kernel internals, of course, what is KMI? This is something that you might have never heard about, at least I had never heard about it before. And so KMI is effectively sort of a curated version of the export symbols that the kernel does. So effectively, Google sort of goes around and says, okay, these things here we're going to expose, these other things maybe not, right? And the idea was that in Android 11, the previous version, you could sort of test against GKI, but effectively forget about shipping with GKI. You could still ship with your own vendor kernel here in the boot partition. And there was a vendor boot partition that was added to simplify the loading of the modules that are required at early boot time, right? So with GKI in 12 effectively being rolled out, to the masses, what the idea there was that you could then sort of depend on Google for all releases of the kernel, and Google has made good on this promise. You could go to ci.nader.com and download kernels that are built there for your product, at least. This is what's been advertised out there. So of course, because Google sort of takes care of the kernel now, or sort of is now issuer, in chief of all kernels, the question then becomes, well, wait a second, I need to change this or that in the kernel. How do I do this? And the idea there was to have kernel hooks so that you can actually sort of do that and hijack whatever functionality that you're interested in. All right. Now, the interesting thing with moving forward, as was explained and by Todd Kios at the Linux Plumbers in this year, is that they're now trying to, in the future, doing upstream first. Okay, so the idea there is to try to get their features instead of, let me just go back here to the sort of evolutionary diagram of kernel releases there with Android mainline and all those stuff. So the idea there is that Google will try to go effectively sort of upstream to the Linus Torvalds kernel first for features, and effectively come from there down all this path that you see here. It's great. I think it's a good idea. I think it's a sort of a great initiative that Google wants to work upstream, and they've demonstrated this by their participation in various community forums over the past few years, namely, for example, at Linux Plumbers and such. And so, for example, one of the things that we've changed in the format of Linux Plumbers this year, and by the way, the videos of that are available on YouTube. One of the things that we changed in the format is there was much more participative. In the past years, there was a lot of Google coming out and saying, "Hey, this is what we've got that's new," and sort of like coming down from the mountain there with the tablets. Whereas in this year, what they've sort of set out to do is sort of go to the community, say, "We're trying to do that. What do you guys think?" And sort of elicit discussion. And it was kind of an interesting back and forth on a number of different topics. But anyway, so this upstream first strategy, I think, is great. It will probably show limitations in that the merging of features upstream is always non-deterministic. Ask the preempt RT guys who've taken about 17 years to merge all their stuff in. So there's a limit to what you can try to do upstream in certain regards. Some things are just really hard to get right in a short amount of time in upstream. So, but it's still, I mean, the goal of being upstream first is fantastic. And I sort of, certainly salute that, and I wish them the best of luck. We'll see how it sort of effectively sort of works out in real life. But that sort of goal they set out, that's at least new to from my point of view, this year is fantastic. All right. So that's for the kernel side. So if you want to remember one thing about the kernel in 12 or in the 12 development cycle is the upstream first perspective. Okay, Apex. So just an update on Apex. So again, those of you who missed prior presentations, what is that? Apex is effectively a modularization of many framework components. So the idea there is, instead of having to do an OTA, a full OTA there to update the entire framework when something goes wrong, instead of that, you take key components and you break them down and you say, okay, you know what, I'm going to be able to update those things piecemeal. All right. So if I want to update the Android runtime, I want to update the media player, I want to update foobar, I can sort of take those things and then update them piece by piece. And if you watch some of my previous videos, I've sort of mentioned my reservations about that. And I had also mentioned that, maybe there was wisdom in what Google was doing in this perspective, and it's just, I wasn't sort of necessarily seeing it. And so, in any case, maybe sort of I'm a laggard, and it takes me time to get used to new stuff. But I'll have to say that Google sort of has continued with the Apexes, and they've sort of more or less made it, from my perspective, into something that's, at least for now, seems coherent, right? I don't know, again, the question of scalability of how many packages could you actually apexize, if that's a verb, going into the future, but for the moment being, it seems to make sense, all right? They've had about 24 Apex packages out there. And the idea behind Apex, of course, is Google can roll those out to everybody that's got an Android device, regardless of which vendor they are, the device is coming from, since those Apex modules are non-differentiating. I mean, the vendors don't really make any money out of differentiating on the Android runtime or the VNDK or this or that. So it really makes sense to sort of keep those as something that Google owns. So one of the things that they've added, that they've added to Apex format this year is the compressed Apexes. So this is the traditional Apex model, and I believe let me see if I'm able to sort of just go here and show you the new diagram that I found. Somewhere down there they have a diagram of the sort of compressed, so let's do this. So this is sort of like the compressed Apex format they have now, where the deal is, if you're going to have multiple Apexes on your device in order to be able to do rollback, why would you keep the stale or unused Apexes in their full sort of uncompressed format? And so you'll see some, I think it's C Apex, the file suffix that you'll see in these on the file system. So those seem to be zipped up and should sort of hold less space if they are unused. Sort of an organic sort of addition to the existing Apex system. Again, this is sort of like the best, not the best, but the newest thing that I can see here with regards to Apexes. Otherwise, the Apexes are pretty much what I described prior. If you are not familiar with the Apex format or want to hear the full discussion about that, then you can go back to my presentation from last year and revisit that. Yes, so let me just slow down here regarding the updates or what's new in the Apex packages. So they seem to say that the COM Android Art was getting an update or was new of 12, or I think where was that module system components? Yeah, here module system components overview. So on their overview here, I was kind of surprised to see when it was a release introduced and they said Android 12 for Art, because I was like, wait a second, I'm pretty sure I saw COM Android Art before. So what is it that's new why is it they say that it's new actually from 12? And if you actually click on it, they give you the full details there. So effectively it says in 10, of 2 versions ago, Art was in the managed core libraries are part of the Runtime module. So this is Android, COM Android Runtime, I think, which is essentially sort of Bionic. In 12, Art and libcore are packaged as non-updatable Apex. So this is what sort of tripped me. It apparently in 11, while it was still there, well, it was there already, sorry, it was not updatable. So you couldn't actually update the actual Apexes, even though when you go to the Apex directory, you do see a COM Android Apex. In 12, though, apparently they are completely updatable. So this sort of fulfills the promise of being being able to update the Art runtime there on the fly. All right. Of course, the Art runtime is the engine that allows us to run the Java code inside of Android. So that's for, you know, and then there's the official list with sort of the other one is, sorry, going back to the same page there. The other one is device scheduling. Okay, so right, so effectively sort of like a management there for the idle state. I have to be honest that I haven't dug into this one too deeply. The one that interested me more, really, to be honest, is COM Android Vert. So this is actually fascinating what they seem to be trying to do here, and this is sort of like just very, you know, conjecture or, you know, based on some of the stuff that I've seen them present in the past. So I'll explain what I've found here that seems to be interesting. Okay, AIDLs, KMI has versions, i.e. the future KMI v1 will be dropped and vendor modules will not work, which has, sorry, let me just reread that question. KMI's versions, in the future KMI v1 will be dropped and vendor modules will not work with new GKI, which has no KMI v1. No, okay, let me just go back to this KMI business. So the idea is that, and I'm not exactly sure that I fully understand the question there, but hopefully my explanation there will make sense to you. So the idea behind KMI is that you are effectively sort of going to be, whenever you standardize on, say, Android 11.5.4, then the API will be sort of coherent and frozen for that version. Now, remember that KMI is based on the existing kernel symbols, so therefore the basis is always whatever the kernel is providing us. So if we're basing ourselves on 5.4, then it's whatever API was in 5.4. So it's not so much KMI v1, v2, v3. It's really just the KMI is a subset of what 5.4 gives us and whatever Google export symbols in addition to what's there by default. So effectively, you've got the kernel already exposing some interfaces, but it's entirely possible that Google might find some stuff that they would like to expose that's not there by default, and then they'll go ahead and actually add those. So so whatever functions exist in 5.4 will be the basis for the Android 11.5.4 throughout its lifetime, right? Of course, when they move off to something else, like for example, the next one was 5.10, so they move off to Android 12, 5.10, well, whatever deltas exist between 5.4 and 5.10, your modules will have to take that into account. So that's not so much dictated by Google as it is dictated by the kernel developers. Of course, what Google will have as a choice is what subsets they expose or supersets if they add some additional stuff. So hopefully this answers the question there regarding the KMI versioning. All right, back to, okay, AIDLs as HALs. So if you recall, it was last time I think with 8.11 or last release, they started to sort of add interfaces to hardware as AIDL instead of HALs. This has just continued, right? And by the way, in response to the video that I did last year, where I was a bit critical about this approach, there was a message or a comment that was posted to the video by one of the folks by the Android team. I believe it was Stephen Moreland, and just to be sure here, not to sort of get the name wrong. Let me just go back to the actual video. So no, I don't want to listen to myself live. I'm only sort of doing that. And do not stream this. Yeah, so Stephen Moreland here, who's sort of explaining or sort of responding to some of the comments I made in my video, which is great. I mean, this is fantastic. Thank you very much, Stephen, for doing that. I sort of understand the general sort of mindset there with the change to AIDL. Again, I'm sort of, you know, nostalgic about the version numbering of Heidel, but, you know, again, as I was saying earlier, maybe I'm just a laggard here, you know, stuck to old stuff where I'm comfortable. So as I said, they just continued on with the AIDelization, so to speak, of the stack. And let me sort of show that to you here. You know, forgive my sort of haphazard desktop here, but this is sort of like my virtual machine that I use for my development. And let me just go here into my sort of hashing down of the changes between 11 and 12. And if we take a look here, let me just open this up and sort of say Emacs. So if I take a look just at the sort of differences in terms of the HALs, so let's go for hardware types additions there. So you'll notice here that, okay, so this is sort of like a, you know, I have a bunch of scripts that go around the sources, and effectively it sort of compares the trees together and sort of comes up with a list of stuff. And so this is, you know, what allows me to sort of quickly see what has been added to a new tree versus another one. So for example here, you've got auth secret AIDL, automotive audio control AIDL, biometrics common AIDL, etc. And so there's a whole bunch of these things that AIDLs that have shown up in this. That were not there before, including, of course, new directories in the hardware stuff. For example, security there is a new directory that I don't think was there before. You've got, of course, new versions of stuff that has been, new versions of Heidels that have appeared. One interesting thing that I've noticed while sort of updating my the class material that I use for my embedded Android class is that nowadays, if you add something to the hardware interfaces directory, and you try to build it, the build system will actually stop you right there and say, hey, wait a sec, you're not supposed to do that. Don't use Heidels anymore. Please use AIDLs instead. Whereas in 11, it didn't actually do that. So they're sort of like gently pushing you into the direction of just don't use Heidels anymore, please. And it's getting to the point where, you know, stuff starts to sort of semi-break there if you continue using it. So anyway, on a multi-year sort of effort there, they seem to be sort of very much committed there to continuing to move away from Heidels to AIDLs. And so one of the things that I noticed as well is when you actually run the tools on the device, they actually have different output now. So let me actually sort of, okay, let's do this. Let's actually grab Cuttlefish. So let me actually just open a new actual sort of terminal here in another desktop. Let's go to my Android 12. All right, so build env setup sh, launch in this case, cf blah, and let's do a couple of those. Right, again, this one. And in this case, we're going to do a launch CVD. So this is Cuttlefish starting up. And yeah, so while this is starting up here, let me explain to you. So when you shelled into a device and you wanted to see the Heidels that were being used in previous versions of Android, you just type lshal, and that would be sort of showing you all the HALs that were there that are active. Nowadays, they sort of are more specific into the output. So if I do lshal like so, you'll see that actually in the output, it actually says, the message sort of subtly changed, and I realized it just because the scripts that I had were sort of stumbling on this. So now they say all Heidel binarized services, whereas this word Heidel here was not there in previous versions of Android. So anyway, so these are the Heidel stuff, because now if you do a service list, which lists the system services, you're going to see, let's just do grep Android hardware, right? So now you actually see in the service list a bunch of hardware stuff because they've been sort of AIDelized. instead of being sort of displayed or advertised through through Heidel. So this also is something that came up in the scripts that I ran. Okay, so that's for HALs and Heidels. Again, there's a few more hardware stuff that has appeared. What is the new hardware? So if you forget sort of like the actual versions that have been added. So I think that you've got here, so this is Genesis idle. Just looking at the top level directories here, I think the security directory here is the new one that I had not seen before. Otherwise, most of the other things are just additions to existing hardware types that were there before. Okay, now last year, if you recall, in my video when I was going through some of the directories I mentioned that I saw in the external directory, Rust directory, I was like, oh wait, what's that's interesting. What are they going to do with that? And of course, we know now that the new sort of Gabbeldorsche Bluetooth stack is Rust based. And there has started to be some, Rust creepage around the code base here and there. For those of you who have not been following that sort of show on the side there, the Rust has been gathering interest and sort of pace in some quarters, especially in, say, where it's been discussed very heavily is in this year's Linux Plumbers. There was a lot of discussion about its integration into the Linux kernel. And it appears that somewhere in the future, TBD, it's poised to sort of make an entry, if nothing else, just for kicks. At least that's sort of like what I'm reading into Linus Torvalds on this topic there, where I think he was saying that what's the point of doing a project if you can't have some fun from time to time or something of that nature. It's primarily being sold as a security thing, and I sort of get that point. But to the people that had come to make a presentation about this at the Android Micro Conference, what I mentioned is, another selling angle, which I think is more interesting, is maintainership. Subsystem maintainers, sometimes have struggle to sort of vet incoming code. And I think Rust has a value there. If it makes it simpler for, maintainers to sort of accept external drivers, I think that sort of is cool. Of course, Google has a strong focus on security, and increasingly so on Android, as we'll see actually in a moment there. So it sort of makes sense that they're sort of starting to spread Rust a bit here and there. I don't know how far that's going to go. It's always sort of hard to sort of just drop stuff that already works. So stuff in Java, stuff in C, and so on. Why would you rewrite new stuff? But they have sort of started, adding Rust-based stuff here and there. It seems, for example, that the Keystore 2 implementation, which, in as far as I can see, seems to be new there, is based on Rust. Let me, if I can sort of just grab this here, build env setup sh lunch again. Not this one, that one, and let's open another Emacs window here. So if you go to System, Keystore, or I'm sorry, where's that? It's security. Sorry, that's right. So security and Keystore 2. So this here effectively is based on Rust, and according to what I was doing in the research with my scripts there, is, remember I told you that I got some scripts that go through sources there and find some stuff. So one of the sort of additions and removals there, so for example, you go to the process list additions, aside from the all the applications and stuff, what you see here is you've got Keystore 2 that's been added to the list of processes that runs, and the scripts pick up that one of the things that's been removed is the original Keystore there that sort of is no longer running. So somewhere they've sort of replaced it with a Rust-based implementation. Interesting, security-based, makes sense to sort of go to Rust. But anyway, we'll see how this progresses over the years, how they go to increasingly add some Rust-based stuff or not. Okay, cross VM. So this actually was the subject of some intrigue or interest by a bunch of folks who are sort of course, downstream or outside of Google. And there was actually a article that I just retweeted, and you can sort of find it on my feed there. Not but this guy here. So there was a few articles there by this was Michel Rahman that sort of described effectively what he had found on the cross VM work that Google's been doing. I looked at that and I sort of delved into some presentations that I had seen being done in the past, and I sort of think I see where this is going with this effort they're doing. Of course, this is a bit sort of speculative on my part, but some of it's backed by presentations that were made, and specifically two presentations. One that was made at the Linux Plumbers in 2020 by Quentin Perret, and then the other presentation was done at the KVM Forum 2020 by another gentleman by Google. I can't recall the name. I'll find it in a second there. Regarding effectively the need they're trying to solve and the problem they're trying to go with this. And so in order to understand what they're doing with this, you have to sort of completely forget about Android for a second and look at the underlying technology that surrounds security on mobile devices and ARM processors in general, right? And what I'm going to do here is I'm going to pull some slides from my Android Security Internals class, which they're all open source, by the way. You can go get them right now, just to sort of show you around a bit the idea of security and how the actual security model that's found in these ARM silicon is actually sort of strongly sort of tethered to, or Android strongly tethered to it, I should say, the reverse. So let me just go here to here and Security Internals. And let's just go grab the slides from here. So this slide around, say 150 or so, or something like that. Right, so this is the boot model that that is actually sort of being used in Android. And this chart is going to be a bit incomprehensible unless I sort of back up a bit and sort of talk to you about Trust Zone for a second. So let me just go find a actual Trust Zone slide here for a second. And that's not too bad. Right. So, okay, let me use this diagram. In an ARM processor, okay, you have this recognition that some components, say for example your ARM core, right, can transition between secure and non-secure world, and some things are going to be secure and some not secure. Right, so what's going to be secure? The trusted boot ROM, trusted RAM, trusted clock, one-time programmable fuses, whatever it is, and so on and so forth, right? And some stuff is configurable, can be other way, and something is just not secure, right? So different components have different security sort of tags assigned to them or responsibilities assigned to them, and the way it works is that the processor core here, which is where your actual code is running, or most people's code is running, is going to emit on an interconnect, which is, think of this as sort of like a networking fabric there, linking all this stuff together, is going to emit the status of the security bit that says whether it's secure or not secure. And I've got some other slides here that expand on this in much greater detail. The idea is that you are then able to effectively have sort of like a dual brain on your processor core, where you have a normal world on, as you can see on the left-hand side here, and a trusted world on the right-hand side. And the silicon can transition from one to the next, and when you're running in the trusted mode, the instructions or access that you do on the bus is going to actually say this is trusted, this is not trusted, and so on and so forth. And then you can effectively run some trusted operating system here and do all sorts of other things with that. All right. And this then allows you to sort of, going back to the sort of boot diagram I was showing you earlier. So this, if I can actually find it quickly enough. Right, this then allows me to sort of have a secure boot environment. All right. So I think I did a Android security internals video a while ago, so you can go check that out. So essentially, my silicon here boots up, gets a secondary bootloader, checks that it's properly signed, boots a bootloader, boosts a trusted execution environment, and then Linux goes off from the bootloader into its own world, does whatever it has to do, right? And this sort of guarantees that when, as a manufacturer, you ship a version of Android out, that the user is running an authoritative version of the code that you actually minted in your build. Okay. The trouble that Google seems to see with this is that effectively the trust zone architecture is not to their liking. All right. And they're not saying it that way. All right. My experience with the folks from Google is they're fairly diplomatic in their presentations and stuff, but my take is really Google's calling BS on this whole thing, because effectively there are some serious problems with this architecture, in that the trusted execution environment effectively have say over everything else. They're sort of given a free rein. They're assumed to be secure, trusted. But as one presenter called it, I think he said, this is a bit of marketing speak. So maybe it's not so secure as it should be. And in fact, if you don't believe me, you can go to the presentation, which I just alluded to, which is my security internals class slides. And I've got a repertoire there of a bunch of attacks that have been pulled off on Trust Zone. There's a bunch of several-year-old now articles by Gal Banyamini on how you can effectively you hack Trust Zone to effectively retrieve the hardware unique key that's in the processor, and maybe this has been fixed, I don't know, since then. But anyway, some entertaining stuff there about how you can attack those trusted execution environments. And in fact, the trusted execution environments in general are a bit problematic in the sense that they're a very closed world. There's not much documentation about these things. Of course, there are proprietary products, which also means that they don't get a lot of eyeball reviews and that sort of stuff. All right. So the idea there is to possibly use KVM to isolate trusted code and run Android and the trusted code sort of side by side underneath a common hypervisor. At least that's what I'm gathering from the presentations that I've seen them giving, and the documentation that they've been doing. And to that end, they seem to be wanting to leverage CrossVM. What CrossVM is effectively, according to its own documentation, the solution being used to run Linux/Android on Chrome OS. So if you go to your device there, and I believe it's my other desktop here, right? So if I'm shelled right here. If I go to Apex, you'll see there that there's a new package called com Android virt, and this is actually not built on all architecture. This is actually, I'm running Cuttlefish, right? So this is the virtual environment for running Androids on a cloud instance. So if I go into that directory here, com Android virt, and let's go to bin, right? You'll see there that it's got the CrossVM binary in there, and so CrossVM is a tool that sort of interacts with KVM at the kernel level to run a hypervisor. So I've gone ahead and sort of stolen a few slides from their presentation there, and let me sort of just get a full screen here. Some of their presentations, and I put the links there again. I'll post the slides later on. So this sort of is another view of the actual sort of security environment that you've got on a ARM processor. So normal world versus secure world. So Linux runs here effectively on a kernel with applications, and of course a hypervisor is supposed to actually be able to run multiple kernels, but this is actually not happening. And in the secure world, effectively you got you could have a hypervisor, which you don't really. You have a trusted OS there with some trusted applications, and they have sort of effectively, access to pretty much everything on the system. They're supposed to be trusted with things like crypto, DRM, playback, et cetera, a whole bunch of things that are happening in the system. So the argument that Google makes is that de facto, this is the real sort of privilege level that you have for those things. So the secure world really has effectively untethered sort of privilege over the rest of the system, whatever it is that you might be running there. So. And this is sort of like another presentation. I'm like sort of mixing two presentations that were given around the same time frame there by two different folks. And yeah, so the other presentation is the one that's right here, and this is by Will Deacon. I'm so sorry, Will. So yeah, so this is a presentation by Will regarding the actual problem with this trusted thing, right? So we suppose that this stuff is trusted, but it may not necessarily be, all right, for whatever reasons, including the fact that it may not actually get as much visibility or eyeballs reviewing the code there from as open source stuff in general. So what is actually needed? At least this sort of like, again, the problem statement that is being put out by Google. So we need something that's open source, easy to ship and update, supports guest memory protection, trustworthy. And there's another point here which is not actually in the slide, but another one, and that is architecture independence. This, I think this one's from a presentation by Quentin Perret, and then the other presentation by Will actually goes and lays out actually the argument for the architecture independence. So the idea there is, could we just not, take cross VM and then effectively take all the secure stuff that's there, run it on a common hypervisor side by side with Linux, but not effectively allow either of these to access each other, and effectively sort of, cut those two worlds apart in such a fashion that one can't really sort of access the other too much. And so this is effectively what seems to be the solution being adopted with this cross VM work, which is to say, okay, you know what, we're going to use cross VM as the solution for that. It's it's got Rust, this is check. As I said, they're pretty enamored with Rust these days. So this is another selling point. But this actually, I think this is one of the things that I like, is that it's actually, if we're actually able to pull this off, then we have a cross architecture sort of solution for isolating those two worlds apart, right? Because the other ones, like TrustZone or whatever Intel's got, or whatever RISC-V has these days, they're all sort of architecture-specific solutions to the same problem, which is to say, I want to run trusted code beside untrusted code. And if I can come up with a common platform that allows me to do this, then that's great, because then I don't really care what processor I'm running on. Of course, additionally, I don't really need to care for these proprietary packages, because all of a sudden I can have this sort of entire sort of Android-y, Linux-y sort of world that I can sort of certify or whatever else, and go with this. And there are also sort of, I didn't put the slides in here, but there was another presentation at the Linux Plumbers from 2020 about the use of virtualization in the automotive world. So automotive, for those of you not familiar with that segment of Android usage, of course, is taking off quite heavily. There are a lot of, we were with a lot of customers who have been putting Android on automotive use cases or scenarios. So definitely this is something that's on fire these days. And automotive does benefit from being able to virtualize to a certain extent, since certification requires being able to make some statements about the solidity of whatever is running on your device. And of course, Linux and Android being too big, there's a few things that you can't actually do certified in that regard, so you can't really trust them. However, it would be good if I would be able to have the same sort of system running on, say, for example, my instrument cluster, and also sort of my entertainment system, IVI, not two different things, not two distinct things, but a same thing. And right now, that's not so much something that you can do, and you can actually see that in their in Google's own documentation. So if you go to, say, source.android.com there, and I go to where's that again? So this is, sorry. Right, so going to, I believe it's the automotive business here. So automotive, yeah, so you go to display or whatever it is they have in here. Audio, display, overview. Right, so you look at this graphic here, and let me just zoom it in a bit. So as you can see, you've got this Android OS on one side and then safety critical OS on the other side, and they don't tell you that sort of this is running Android. So effectively, this is, say, my IVI there, and I'm possibly sharing some graphic buffer with some safety critical OS running on some cluster, instrument cluster, separate from my Android, and the instrument cluster is sort of safe because it's running a safety critical operating system. So if you unify those two things, in this, it will sort of reduce your BOM there for effectively running whatever it is that you've got to run. Sorry, you got too many windows open here. So yeah, so I think that's my understanding of where they're going with this thing. It's one of the things I was curious is after seeing it in the Apex directory, was like, oh, are they running this? And you sort of look at the process list, and not really. They don't seem to push anything in there. But maybe sometime in the future, TBD, they just you spawn effectively Android, and then the trusted thing on the other side there with this cross VM, and both of them are sort of like on the same footing. Based on at least the diagrams they've been putting out and explanations they've been giving. And so the boot process then sort of looks a bit like this. So if you sort of contrast this with my other diagram, where effectively your secondary bootloader here loads a bootloader for getting Linux online and then a trusted execution environment, it seems that in this case you would forego this, or maybe in addition to that, I'm not sure, you would actually have the bootloader load Linux and then some trusted thing on the side there. And the way this works, apparently, at least the idea behind it, or the architectural idea, is you boot yourself a generic kernel here with the hypervisor, and then the hypervisor, being in a separate section, sort of protects itself and sort of takes over there into a protected KVM mode, and then you get yourself the generic kernel continuing on its merry way with GKI stuff as it would do, but then you get yourself this protected environment there where you can then sort of take care of launching sort of secure code or whatever it is that happens afterwards. So that'll be interesting to watch what this does over the next few years. I suspect that probably one of the things that's going on there behind the scenes is there is some, of course, discussion and back and forth between Google and the people that want the secure environment stuff, be it their own security staff, and also, of course, people doing DRM and who need DRM and who I should say mandate DRM on devices for secure playback, who will want to be able to have a say there on this. So probably that's there's some convincing that has to be done, right? Aside from just putting this thing out there. There has to be some demonstration that it is indeed secure and then can be used for, running secure stuff on the side. So again, it's very speculative here on my part, but that seems to be, based on my understanding of what these secure enclaves do. This seems to be a solution to this problem, where since these systems tend to be proprietary, they tend to be architecture specific, they tend to be actually completely different APIs from regular APIs, being able to sort of leverage Linux and Android itself, we could probably, maybe spawn some mini Androids, in fact, which is one of the targets that Michel was describing in his post there, sort of this mini droid, I think, or micro droid that was being spawned. So, maybe that's one way to sort of put stuff in there. So I think this is the biggest piece that I've seen sort of wind its way into 12. Again, right now sitting idle. We'll see in the future what actually happens with this. So let me actually sort of go through some of the, and the slides are blank here, so I didn't bother. I'm just going to run you through the output of my scripts there. I'll show you what's been added in different parts, what's been added to ADB and the different file systems and so on. And feel free to post questions or comments as I go there if you have any sort of, integrations or anything like that based on what I'm showing you. So I start with ADB because this is sort of like the the day-to-day tool of the most anybody doing internals work inside of Android. So if you take a look at what's been sort of added to ADB there, so you've got this MDNS stuff that's been added there. So check in services and And these things haven't really been added. Neither the pairing, by the way. So the pairing commands are not new. The MDNS stuff is, but the pairing is not, and neither the push and pull. It's just that they've sort of added some parameters to it. So if you actually look at the actual what's been removed, it seems that what's been added is the algorithm there that you can now specify. So if I go out here back, so push and then -z algorithm. So that's sort of new from 4.12. All right. Okay, so that's for ADB. Nothing really radical here. The HAL additions I showed you, I just went through the list earlier as I was going through the AIDL stuff, so I mostly skipped this. Okay, so AOSP changes, lunch targets, HMM, and all the rest. So let's go take a look at that. So, oops, no, I do not want to close my VM there. Open this back up. So, all right, let's go for the actual lunch additions there that have been made. So lunch target additions, yeah, a bunch of, a few cuttlefish things here, quite a few car stuff, as you can see there, that's been added, yeah, again, car and so on. Yeah, I should say this about 12. So generally speaking, when I grab, forever, since my early days of playing around with Android, one of the very first targets that I would build with the AOSP was the emulator, all right? I just build AOSP and then sort of run the emulator and see what's new. With 12, that did not work anymore. So I built it, and then I tried to launch the emulator, and it was just not launching. Complaining about some user data stuff, if I recall correctly. And try SMA just wasn't sort of happening. And maybe this is just because I was using an earlier version of 12. I was testing this on 12.0.0 R2, so maybe that's been fixed since. And actually, since then, somebody told me that the SDK target does actually build a proper emulator. If you want the classic sort of, GUI emulator that starts kind of like the developers use. Anyway, so for a couple of years now, I've been sort of gently being pushed by the Android team to use Cuttlefish. And my sort of question was, why the heck would I use Cuttlefish? I don't need Cuttlefish. The emulator just did a fine job for me. And then, with 12, sort of like, it did not work anymore. So I was sort of semi-pushed to actually use Cuttlefish. And one of my biggest sort of questions about Cuttlefish for a long time was, why? I mean, why do I need this? Why don't I just use regular emulator? And it sort of makes sense. Cuttlefish makes sense if you take a look at it from the perspective that, say you're a developer at Google, you're working on Android, you're doing a lot of different tests, you have a lot of targets that you want to deploy your code on, et cetera, and sort of running an emulator just doesn't make any sense in that perspective, right? Because then you have to deploy an actual desktop. You have to run that thing on the desktop and then log into that desktop to do this thing. Not sort of conducive, too much of work. So Cuttlefish in that sense sort of makes sense because it's sort of like a cloud instance. You just fork a cloud instance, it does its thing, and if you actually want to see the GUI, if that's something that you want to see, then you actually go ahead and go to the GUI with a browser, but you don't need the actual browser to actually go to you don't need to start or connect to the system there in any case until you actually need to, right? It's all scriptable over ADB or SSH or whatever it is that you're doing. So this makes sense then, from my perspective, why you would want to use Cuttlefish. And so once I've gotten accustomed to it, I'm probably going to stick to that for the future. Again, remember I'm a laggard, right? Sort of, I don't change unless I have to. In this case, they actually forced me. One of the things that you want to watch out if you start using Cuttlefish, their documentation says use the browser. That's a bit misleading because, or at least they might have fixed it. I've actually emailed the folks there and they were sort of seemed keen to fix that problem. So the documentation said browser, and I opened it in Firefox for a couple of tries and I was like, wait a second, what am I doing wrong? This thing doesn't render. And I had bitten by that in the past when Google had come out in 4.1 or 4.2, I can't remember, with the tracing stuff. They had said, oh, you can generate the stuff with systrace and then open it in a browser. Great. And I spent like half a day wasting my time trying to open this in Firefox, and it actually never opened until someone had down on my mind. It's like, okay, wait a second, let me try Chrome. And I tried Chrome and it worked. So anyway, in this instance, lesson learned. After it didn't work a few times in Firefox, I opened it in Chrome, and lo and behold, it actually works in Chrome. So for now, at least in my understanding, unless that's been fixed, you want to use Cuttlefish, you're going to have to use Chrome or a Chrome-derived browser like Chromium, which is what I'm doing right now. The second thing with Cuttlefish that you want to watch out for is the path from which you actually start the Cuttlefish instance has got a limit, right? And that's something that sort of didn't make sense to me at all in the beginning. It was like launching Cuttlefish and it would fail until I sort of paid attention to some of the error messages that it was putting out. And it turns out that if you launch Cuttlefish into too deep of a hierarchy, it won't start. You actually have to make sure that the path is sort of short. Apparently that too is sort of being looked at. So hopefully in the future, this will stop being an issue. In any case, so I can't even remember anymore where I started with this. I think I was talking to you about the lunch targets and Cuttlefish, and then I sort of diverted into the issues with Cuttlefish. Anyway, so close parenthesis here on Cuttlefish. I do recommend that you try that. I think for platform work, it makes perfect sense for working on Android. So after having resisted the change for a couple of years, I'm sort of adopting it wholeheartedly. Anyway, so this is for the launch editions, whatever. This is a removal from the list, not sort of anything super interesting. HMM, so that is, of course, one of the commands that's pretty useful when you're sort of trying to, get shortcuts working with the AOSP. So tapas is certainly not new. But effectively, they changed apparently the list of parameters, so my scripts are picking up the difference. That's been there. A few additional greps, Kotlin and Rust greps, module locations with these out dir mods, install mod, and so on. Rewrite the system partition as reroutable, rebooting if necessary, and then banchan for effectively set up the build environment for apparently building apexes. I've not tried this, so I hesitate to sort of go too far into that. In terms of removals, not sure if there's much to be removed here from HMM. I think it's just it's just picking up on some changes. And yeah, so for those of you who are not familiar with HMM, they also have a sort of like at the tail end of the output, they have sort of like a ton of commands that they don't describe, and effectively if you want to know what those do, you have to go to the actual sources. I've not bothered actually looking at the specific makeup of this. You can probably just run a script there to sort of list the additions for there as well. So that's for HMM. Make help. What was added here? So some new nodes, VD node and OD node. The node things, by the way, are the system images or images that are generated at the end there. So that's for make help additions, removals. I think this is just a path issue that my script is picking up on for that. Build core. Right, so this sort of usually gives you the sort of output of what is going to be different in terms of the new build files. So not sure there is anything sort of extraordinary that I'm seeing in this list, except for, of course, some additional sort of Rust stuff that's sort of being added. There's just continuing the build system here. As you know, the core of the build system is done with makefiles, traditional makefiles. So this is just continues the in this tradition. Devices. So this will of course be sort of coherent with what's been added to the list of launch commands or launch targets, right? So those are new things in there. What's been added from the devices itself, or removed, Cuttlefish kernel and so on. Yeah, so one of the other things that I sort of hit my head against when I was working with Cuttlefish there is Cuttlefish takes its kernel from kernel prebuilds. And there's a slight rub there where if you build your own GKI outside and try to bring it in there, the build system doesn't sort of pick up on it. at least in the case of the modules, easily. So I had to go in and there's sort of, force it by going to the out directory and finding where it's actually copying those modules and sort of just ripping that out and then forcing it to then take the new kernel that I added in there into pre-builts. Otherwise, it sort of didn't pick up on it. Again, maybe just a fluke of the version that I was actually using. Okay, what's new into external other screen? There we go. So AOSP external editions. So basic build, which this is intriguing. I'll follow that a bit. Download Kotlin stuff. Yeah, they tend to sort of add. This external directory varies a bit, quite a bit, I should say, and they keep adding a dozen, removing a dozen, sort of that sort of stuff. For example, they got rid of a U-boot. Forget about AWS. This is my thing. This is not actually from AOSP. Anyway, U-boot here being removed. Again, there's often no sort of direct justification there about what's being added. I do see a lot more additions here this year than last year in terms of stuff into additions. They actually got about 30-some, 40, 50 about additions there into external. Usually it varies about a dozen packages up and down, not 50 like that. So this is interesting. Sort of just as somebody that's been following the AOSP for quite a bit here, and some other folks who have done the same will sort of relate to that. It becomes really hard to track effectively everything that's happening and that's new in the AOSP. It's really tough. There was a presentation actually about that by John Stoltz at Linux Plumbers, which was itself actually based on a presentation he had done at a Linaro Connect. It's really hard to keep up with the pace, and I actually believe that's sort of true within the Android team itself, even though this may not be advertised outside it. The operating system has become very complex. And every year when I do this, it's sort of like, I'll have to confess to you, sort of a bit stressful, because I'm like, wait, am I going to miss something that's important that in my presentation? And that's entirely possible. The system has gotten very, very big. So some people ask me about updates about books and stuff, and I'm like, yeah, but always in the back of my mind here is that this is like a bullet train. I'm chasing it, trying to understand, keeping up with the stuff. It moves really fast. They keep changing things, fundamental things, and sometimes left hand doesn't talk to right hand, and there's no sort of central repository that says these are the entire list of things that have changed. Of course, what I said in past presentations remain true. They do publish a list of changes, sort of an official list of changes that's on source.android.com. So if you go to, this is something that you'll find up there, so source.android.com, you go here, documentations, and I cannot remember where this was. See, this is, come on, I think it's down here somewhere, release notes, there we go. So yeah, Android 12 release notes. So you have a whole bunch of list of stuff in here about what was added, what was changed, and so on and so forth. And it's a good starting point. Okay, it's not a bad thing, but it is not in and of itself, the full explanation of some of or justification for some of these things. So personally, when I look at these things, I'm interested in architectural changes. That's just my personal area of interest, right? I'm not so much interested in the specifics that they've added to the audio or the camera or whatever, and if that's your area of expertise, of course, it's entirely justifiable that you'd want to spend time investigating this. But my perspective is like, okay, is there a new communication mechanism? Is there some sort of new build mechanism that's not been there before? So this is where things like Apex will sort of focus my attention, or things like the cross VM stuff that's there. Those are like sort of significant sort of tweaks to how the architecture works. Those tend to not be they don't tend to do many of those in any given release, right? From that perspective, those tend to be rather sort of contained in terms of numbers, whereas other stuff like packages being added and that sort of stuff internal changes to the AOSP are massive. So okay, going on to the continuing here on my list of stuff that's been changed in the AOSP. So I showed you external frameworks. I can't remember. I think I didn't even bother to look at the output here from there. Yeah, proto logging. Yeah, nothing sort of major in there. System I think has a few things, sort of a AOSP system. Logging, a few things like that. Again, I closed my VM for no reason. System, the native user space. Okay, what about the init process? So this is a bit in the weeds there. When I start talking about that, you get into the sort of very sort of down dirty sort of details there. Let's go to actually my other desktop if I can actually get to it. It seems that I cannot get this guy to respond to what I'm trying to do. Let's try this. Let's go to full screen mode. And he's still not doing it for some reason, which I don't understand. Nope. Okay, now he's responding. Okay, so yeah, the init changes. So let me take you to that. That's not what I want. Neither this. Actually, let's close the browser. So let's go to init RC differences, right? So I've gone through this, and honestly, I didn't see anything that's sort of super radical. Of course, they always have changes in that. So plus or minus a few lines here and there. Tracing stuff, entropy, key store. Yeah, I don't recall seeing anything here that's sort of like, wow, I discovered something new. Some Linux tweaking. Yeah. Mostly regular stuff in here, sort of. Again, it usually shows up when they've got something pretty. You'll imagine that they've got, of course, changes to the global properties. That's usual. Mount. So the mount output a bit sort of was sort of surprising to me when I sort of visited it while doing some of the hands-on with some of my previous classes. It seems that now, in addition to the Apex stuff, they're also right. So yeah, they're mounting the Apex not just in loopback but also as over device mapper. I'm not exactly sure why that is. If you have an explanation for that, hey, feel free to post it either in the comments of the video or here in the chat. But I'm not exactly sure why this, and sort of like the loopback stuff is still in there as well. So I'm not entirely clear what's going on there. Maybe I'm not paying attention. Process list, what's new in the process list in there? Process list additions. So yeah, of course, ignore all the hardware stuff, right? Android hardware blah, this is sort of just expected. And of course, applications sort of change names because the script sort of picks up a change even though the application might not have changed because the application number changed. We don't really care. Okay, so key store 2, that is the one I mostly noticed, and that's pretty much it. There's a few additional things here and there, but nothing sort of radical. Over the file system, I'm not sure that there's much here to be said. Unlike last year when they were sort of exposing new sort of changes to, and I'm trying to get to the list here. System bin, root top additions. Yeah, again, nothing here too radical that I have to point out. lib64 additions, you can see there's a whole bunch of these hardware things that have been added. That's sort of usual. But this sort of list is a bit dull to look through and hard to sort of decode. You have to look at it from the other sort of side of things and look at the architecture additions that have been made here and there. So yeah, that's pretty much it here really. That goes through pretty much everything that I've seen there up until now in 12. I must have missed a few things here and there, and if so, please, feel free to either post it now in the comments in the chat there, or later on as a comment to the video. Most welcome to take any corrections at some point in the future if that's necessary. So from my perspective, it's mostly fixes on the fringes, the natural sort of evolution of AOSP being what it is, a really big project with a lot of moving parts. So it's not unnatural to see a lot of things changes, a lot of things change. As I said, I try to focus on things that architecturally are significant. From my perspective, the one which I mentioned is cross VM sticks out, but some other things might be there as well. And so I'm happy to take any questions at this point in the chat. Otherwise, that would sort of wrap it up on my side there. And I'm happy to sort of, again, take up any additional comments that might come in the future over, the YouTube commenting system itself. I'm just going to sort of wait here online since the delay, the broadcasting delay is different from people in different regions of the world. So I'm just going to give an opportunity here for everybody to possibly comment if there are any sort of comments to be. So since there isn't much that seemed to be coming through, well, I'm gonna just thank you for having attended. I'll wish you, of course, happy holidays, Merry Christmas, and a great 2022. And yeah, that's a wrap for today. I'll see you guys hopefully in the future. All right, take care. Bye bye.